Welcome to Understanding Electronics, microcontroller part 74. This is the first part of the 74 which deals with the tiny microcontrollers. Objective of this presentation: to select correct mini microcontroller for a project. Definition of a mini microcontroller. A mini or small microcontroller is a compact integrated circuit engineered for low-cost, space-constrained and low-power electronic applications. Unlike the full-sized microcontroller that features dozens of pins, these miniature versions focus strictly on the essential computing functions to minimize physical size and power consumption. Common real-world uses of the mini microcontrollers. Small microcontrollers act as smart logic component in modern electronics. They are widely used for consumer goods, power management, signal conditioning, LED control. Core defining characteristics of mini microcontroller. 1. Low pin count. 2. Microscopic physical footprint. 3. Resource optimization. 4. Single task focus. 3 and 4 pin microcontrollers. 3 and 4 pin microcontrollers exist, but they are highly specialized, ultra small chips used for basic logic, power management or time delay functions. Because a standard microcontroller requires at least 2 pins for power, a third pin or fourth pin leaves only 1 or 2 pins for input-output operation. 3-pin microcontrollers. True 3-pin microcontrollers are incredibly rare because having only one dedicated input-output pin severely limiting the functionality. However, some chips operate as programmable state machine or logic element. Example of 3-pin microcontroller unit: Sheligo, Dialog, Renesas, Green Pack series. Example SLG 46110. These configurable mixed signal IC that function like a tiny ultra low power microcontroller. In microscopic scale package, some variants use as few as 3 active pins to perform basic timed logic or hardware state squeezing. 4-pin microcontrollers. 4-pin microcontroller provide 2 I/O pins, making them highly useful for simple tasks like reading a single sensor, driving an LED blink pattern, or acting as an intelligent power switch. While normally sold in 6-pin packages, microchip manufacturers these ultra-small 8-bit AVR chips in 4-pin UDFN or wafer-level chip scale package. They pack true AVR processor up to 1 kilobyte flash and 32 bytes of RAM into a footprint smaller than grain size. Example of 4-pin microcontroller: PTC series, PTC 152, PTC 161, PADOC, is famous for ultra-cheap penny microcontrollers. Several of their variants are offered in 4-pin packages. Package type available DFN4 or SOT234. They are widely used in mass-produced consumer goods like cheap toy, electronic toothbrush, and timed holiday lights. 6-pin microcontrollers. 6-pin microcontrollers are highly popular and widely used in consumer electronics. Conversely, 7-pin microcontrollers do not exist as standard package type, though they occasionally appear in modified form. 6-pin microcontroller, highly common. 6-pin microcontrollers are widely manufactured because they allow exactly 4 input-output lines alongside 2 necessary power lines. They are commonly available in tiny, easy to solder SOT236 packages. Example, microchip PIC-10F family, 80 tiny series, Paduk Penny MCU. 7-pin microcontroller, virtually non-existent. There is no standard 7-pin microcontroller category. Integrated circuit manufacturing relies on symmetrical package style like 4, 6, 8, 14 or 16-pin to optimize manufacturing, automated assembly machine handling and PCB layout. However, 7-pin count can appear in 2 edge case scenarios. Edge case scenarios. Scenario 1, power management IC. Scenario 2, custom multi-chip modules. 8-pin microcontrollers. Common 8-pin microcontrollers are manufactured in AVR and PIC families. AVR family overview. The AVR family of 8-bit RISC microcontroller introduced in 1996 by Atmel. The present ownership is by microchip technology. The key group in this family are Tiny AVR, Mega AVR and X Mega AVR. Core architecture and features. RISC design, hardware architecture, on-chip memory, general purpose registers, contains 32 working registers connected directly to CPU logic. Main types in the AVR family. 1. Tiny AVR. 2. Mega AVR. 3. X Mega AVR. AVR 80 Tiny series. 80 Tiny 13. 80 Tiny 25. 80 Tiny 45. 80 Tiny 85. 80 Tiny 12. 80 Tiny 202. 2. PIC family microcontrollers. The peripheral interface controller is a family of microcontrollers introduced in 1976 by General Instruments, now developed by microchip technology. The main group in these families are 8-bit, 16-bit and 32-bit microcontrollers. Core architecture and feature. Modified hardware architecture. Streamlined instruction set. Extensive peripheral support. Strong legacy control. Main series in the PIC family. PIC 10, 12, 16, 18 series. PIC 24, 16-bit series. PIC 32, 32-bit series. PIC series microcontroller numbers. PIC 12F508, 509, PIC 12F 629, PIC 12F 675, PIC 12F 683, PIC 12F 1822, PIC 12F 1571 and 72. Selection criteria. Do you need analog digital converter? How much flash memory you need? Do you prefer through-hole, dip or surface mount technology? The page here shows the table with specification comparison of AT-Tiny85, PIC 12F 683, PIC 12F 1840. One can compare and select the microcontroller according to their choice. Key differences to keep in mind. Architecture. AT-Tiny runs on AVR RISC architecture. This architecture executes most instruction in single clock cycle. PIC MCU divide the external clock speed by 4 to get the actual instruction cycle speed. Hardware programmers. AT-Tiny can be programmed using Arduino Uno as ISP. PIC microcontroller require dedicated proprietary programmers like Picket 4 or MP Lab Snap. Flashing method. Programming PIC 12F683 using standard Arduino as ISP sketch is not possible. Physical wiring layout completely different. AT-Tiny85 uses standard peripheral interface protocol for programming. PIC microcontrollers rely on proprietary microchip protocol called in-circuit serial programming (ICSP). Decision making. First point to be considered for making decision is the processing performance. AVR architecture enables single cycle execution. This means 1 MHz is equal to 1 million instructions per second. PIC architecture requires 4 clock cycles per instruction. 4 clock oscillations is equal to 1 instruction cycle, making it roughly 4 times slower than the same clock speed. Decision. Choose AVR if your application needs fast mathematical execution, real-time data processing or complex algorithm. Second criteria, form factor and pin constraint. PIC Mini, PIC 10 and PIC 12 available in ultra small low pin count packages starting from just 6 pin. AVR Mini Tiny, most common variants start at 8 pin, though newer ultra tiny chips offer smaller packages. Decision. Choose PIC if your PCB space is extremely tight and you only need 3 or 4 I/O pins. Specialized hardware peripheral. PIC peripheral feature independent peripheral like configurable logic cells which handle hardware tasks without using CPU power. AVR peripheral. Standard straightforward peripheral ADC, timers, SPI, I2C that heavily rely on CPU interrupts. Decision. Choose PIC for complex hardware automation. 5. Ecosystem and software development. AVR ecosystem. Massively supported by open source community, highly compatible with beginner friendly Arduino IDE and GCC compilers. PIC ecosystem utilizes microchip proprietary MP Lab X IDE and XC compilers which are highly stable for industry certification, but have a steeper learning curve. Decision: choose AVR for rapid prototyping, hobbying projects, or quick software development. Wiring scheme of two families. The VDD and VCC denotes the positive power supply. Ground VSS denotes the ground power supply. Reset programming voltage and data clock, data input output pins are defined in this table. Programming tool needed for AVR family. This page shows the simple wiring of 80 tiny with Arduino Uno. The Arduino Uno is flashed with ISP program, and this transfers the program to 80 tiny through master slave method. Remember to connect a capacitor in the circuit to program 80 tiny properly using this circuit. Programming tool needed for PIC family microcontrollers. Programming PIC 12F683 options. If you want to program the PIC 12F683, here two primary options. One, standard method recommended. Buy a dedicated hardware programmer like Microchip Picket 4 or MP Lab Snap. These connect directly to the Microchip MP Lab 10 IDE. The Arduino as a Picket programmer, Hack Advanced. There are open sources community made projects where developer have written entirely custom Arduino sketch to mimic the PIC programmer. This setup requires building an external transistor circuit on your breadboard to set up Arduino 5-volt output to 13-volt needed for PIC MCLR pin. The image shows the K150 PIC programmer, which is used for PIC family programming. PIC 3.5 Kit 3.5 programmer. PIC 3.5 in-circuit debugger programmer compatible with microchip, uses in-circuit debugging logic incorporated into each chip with flash memory to provide low-cost hardware debug and programmer. The PIC 3.5 allows debugging, programming of PIC and DS-PIC flash microcontroller using powerful graphic user interface of MP Lab integrated development environment. This is an upgrade from PIC 3 programmer with programming to go feature. PIC 3.5 wiring table is given in this page. Architectural and software roadblocks. The software limitation. The Arduino IDE as ISP software inside Arduino IDE is explicitly coded to talk to AVR chip. It does not understand ICSP commands or timing required to write data into PIC chip flash memory. Voltage variation. The 80 tiny flashes comfortably at standard 5 volt. However, older legacy PIC like PIC 12F683 often require high voltage pulses, 12 volt to 13 volt on the reset pin to enter programming mode. The Arduino Uno cannot provide such a external circuitry. Physical wiring differences. Physical pin arrangement of programming these two microcontrollers are entirely mismatched. Cannot be one-to-one substitute. Conclusion. The 8-pin 80 tiny is a clear winner. Requirement of dual voltage level for programming is a big drawback for PIC family. Both 5 volt DC and 13 volt DC power supply needed for PIC family. Programming of 80 Tiny 85 and PIC 12F683 will be published in the next episode. One can contact the author for tips, support, assistance and guidance. Please contact for code and support. Kits are available for learning. Projects for schools and colleges can be designed. Contact the YouTube owner. Subscribe to my YouTube channel. Please subscribe to my YouTube channel by following the link. Thanks for watching. See you in the next episode.